In this video, we're going to talk about vectors. We're going to look at practice questions on vectors in physics. Okay, so a displacement d of 100 meters from the origin at an angle of 7 degrees above the x-axis is the result of three successive displacements: d1 of 100 meters along the negative x-axis, d2 200 meters at an angle of 150 degrees above the x-axis, and a displacement d3. Find d3. Okay, so we're going to sketch this problem and help us analyze the way to go about it. So we are saying a displacement d is as a result of three successive displacements. So meaning that a displacement d is actually a resultant of the addition of the other vectors d1, d2, and d3. Okay, so how do you get to express that? So let's try to first of all sketch what we have. So let's say this is our XY plane. Okay, we'll start sketching. So we'll try to forget about D first of all and start with D1. So D1 of 100 meters is along the negative x-axis. So the negative x-axis is this side. So it's 100 to the negative x-axis. That is our D1. Okay, D1. Then our D2, 200 meters at an angle of 150 degrees above the x-axis. So 200 and, an angle of 150. So an angle of 150 somewhere here. So this is the angle that it has made with the x-axis. They are saying it's above the x-axis. So an angle of 150 degrees. Well, the magnitude is 200. So we'll indicate the 200 there. So this is our D2. Then D3, we don't know where it is. So let's try to come up with a table that is going to help us. Okay. So we need to resolve the vectors, the given vectors, into their x and the y components. Okay, so the vector 1 that we have is D1. We also have D2. We have D3. Then after adding these, what we are coming up with is the what? The resultant D itself. Okay, so D. So indicate our D there. Okay, so this is our table, that is our x, and that is our y. Okay. So what do we need to know? We need to know how to resolve the vectors into their x and the y components. So whenever you're given a question under vectors, I would advise you resolve the vectors, resolve them into their x and the y components. It will be easier for you to work out the solutions. Okay, let's start. So D1, we are told it's 100 meters along the negative x-axis. So the x-axis is it's negative 100. How about the y? So when something has moved along the negative x-axis, when something is moving along the x-axis, it doesn't make any displacement in the y. So therefore our y component is 0. Okay. D2, we are told is 200 meters at an angle of 150 degrees above x-axis. Okay. So you need to know that the x component from trigonometry is determined by the vector that you have r multiplied by cosine the angle. Okay. The y on the other hand is going to be given by the vector that you have sine what? Sine the angle. That's the way you need to resolve a vector into the x and the y component. So D2, we've been told the angle, and make sure that the angle that you're dealing with should always be measured immediately from the positive x-axis. So in this question we are lucky because we've already been told it's 150 degrees above the positive x-axis. So we can just use the 150 that we've been given. So the vector that we've been given is 200. So for the x component, it's going to be 200 cosine the angle 150. So we'll get negative 173.2. So we have negative 173.2. Then our y is going to be the same, 200 Instead it will be sine the given angle 150. So it's giving us 100. Okay. So have we been given anything for D3? Nothing. And they want us to find it. So we can just put anything there, any letters to denote what we want. So we can say that is our X and that is our Y. Then the displacement itself has been given to be 100 meters from the origin at an angle 37 degrees. So the angle has already been given to be above the positive x-axis. So let's try to show that. Okay, so if you look at the x-axis, the xy plane, it's 100 meters, 37 degrees, so the angle is 37, yeah. Okay. So this is your y, and this is your x. So from trigonometry, y is opposite to the angle there. So that's why it's sine 37 is actually equal to your y is the opposite. So over what? The hypotenuse in this case. So the hypotenuse is the given vector 100. So this explains why the y is determined by the vector sine the angle. For the x, it's going to be cosine the angle x over that. So that's where these are coming from trigonometric ratios. Okay. So let's try to come up with space. So we're trying to resolve our vector, our displacement, into the x and the y components. So we've been told the vector itself is 100, so the angle is 37, so it will be 100 cos 37 for the x-axis, which is 79. So we have 79.9. Then for our y, it's going to be 100 sine 37, which is 60.2. So what we've come up with, guys, is we've resolved the given vectors into their x and the y components, but we need to find x and y for D3. Okay. So how do you go about it? So remember from the question, D was actually a resultant of these Haber vectors. Okay. So meaning that when you add all the x components, they're supposed to sum up with 279.9. When you add all the y components, supposed to add up to 60.2. So that becomes easier because you'll be able to find the value of what? The value of x. Okay, so we have negative 100 plus negative 173.2. So after adding this and this, I'm getting negative 273.2. So negative 273.2 plus x. So I need to add x. After adding, supposed to give me 79.9. Okay. Because D was a resultant of these other vectors. So taking the 273 the other side, it becomes x would now be the addition of 79.9 plus 273.2. And what I'm getting is 353 point what? 0.1. So that is our x. We can now find our y. Our y will be 0 plus 100, which will just be 100 plus y, which is supposed to be equivalent to 60.2. So what happens after subtracting the 100 from 60.2? Our y becomes equal to what? Okay, so 60.2 minus 100, it becomes negative 39.8. So we've determined the x and the y components of D3, but they want us to find the displacement itself. Okay, so by now you guys should understand that when you are given the x, remember this is a right angle triangle, so you have your x and your y. For you to find the hypotenuse, it's supposed to be this the square root of the square of the two adjacent sides. So you find that side to be the square root of the squares of the two adjacent sides. Okay, so equally in this case, for us to find the vector d3, we're supposed to add up the components that we've determined there. Okay, so we're going to have 353.1 squared plus negative 39.8 in brackets squared. So the square root of this is what is going to give us what? The vector itself. Okay. So get your calculator. So you have 353.1 squared plus negative 39.8 squared. The square root of that. So I've got 355.3. So you get 355.3 meters. So this is your displacement. Okay, but remember, you need to understand that each time they ask you to find a vector should always have a direction. That is the difference between a vector and a scalar. So each time you ask to find a vector, whether the question doesn't state that you should find the angle, make sure you always find the angle. Okay, so we determined our y component to be negative 89.8, our x component was determined to be 353.1. Okay, so if you look at the x or y plane, our y value is negative and our x value is positive. So expect that this angle is going to be in the fourth quadrant, because in this quadrant, this is where the x is positive and the y is what? Is negative. Okay, so this is where we expect our angle to be. So let's try to determine our angle. So our angle is going to be determined by tan theta, or let me say tan alpha, y over what? Y over x. So in this case, our y is what? So I'll ignore the negative. 39.8 over 353.1. Okay. So 39.8 divided by 353.1, tan inverse of that. So after determining tan inverse of that, your alpha is going to be 6.43. So remember, we had ignored the negative. So for us to find an angle in the fourth quadrant, we are supposed to subtract from 360. So after subtracting from 360, the angle that you found, your theta is going to be 353.6 degrees. Okay, so how do you get to present your solution to the question? So you get to present your solution by, first of all, okay, so you understand that this is your displacement, so you say comma 353.6. so that's the way you should answer a vector question every time. Okay, write the displacement, then show the angle as well. Okay, so the second question is asking us, we've been given the diagram on the right hand side there. Then it says find the direction, the magnitude. Okay, so vector sum a plus b, vector difference a minus b, vector difference b minus a. Okay, so to attempt such a question, what is very important is for you to resolve the given vectors into their components. Okay, so remember we say that the angle is supposed to be measured in respect to the positive x-axis, and we resolve the vectors into their x and y components. Okay, using this formula. So we said for x, it's the angle. It's a magnitude multiplied by cosine the angle. The angle should be respect to the positive x-axis. So for the y-axis, it's supposed to be sine the angle. Okay. So we'll start with A. How do you get to know the angle to use? So we are measuring this angle in respect to the positive x-axis, to a point where the vector is. Okay, so we know that this straight line, the angle is 180. For us to get that angle, it's supposed to be 180 subtract 25, which is going to give us 155. Okay. So we have 155 as our angle there. So for x component, it's going to be 30 cos 155. So we have negative 27.2, negative 27.2. For y, it's going to be 30 sine 155, which is 12.7. So equally, when you move to b, the angle that we're supposed to measure is supposed to be in respect from the positive x-axis and clockwise direction. So it's supposed to move like this. Okay, so we know that a complete revolution is 360, and this top part is 20. So for us to get this O angle, we're supposed to subtract the 20 from 360, which is going to be 340. So 340 is our theta. Okay, so we have 340 as our theta there. Let me write it down here, 340 degrees. So our magnitude is 20, so it's going to be 20 cos 340 for the, so 20 cos 340 for the x component, which is 18.8. For the y component, it's going to be 20 sine 340, negative 6.8. So I have negative 6.8. So we've resolved the vectors a and b into their x and the y components. So now let's try to come up with the vectors that we've been asked to determine. Okay, let's try to do that. So the first question is asking us to find a plus b. So let's indicate that here. It's a plus b. So what this means is you add up what? You sum up their components. So negative 27.2 to start with the x components, plus 18.8. We have negative 8.4. So you have negative 8.4. For the y as well, we do the same. 12.7 plus negative 6.8, we have 5.9. Okay, so the sign that is between the two vectors will guide us on what to do with the components. So we found the x and the y component for a plus b. How do you get to find the vector itself? So remember we said in the previous question that it's supposed to be the square root of the x component plus the square of the y component. So I have negative 8.4 squared. So I have negative 8.4 squared plus 5.9 squared. Of course, not forgetting that it's supposed to be the square root of that. So that is going to give you 8.4 squared plus 5.9 squared. The square root of that. I'm getting 10.2. Okay. So our vector is, so let me just write that on top here. So it's 10.2. Of course, the units were in what? In meters. So 10.2 meters. So we found the displacement. How do we get to find the angle? So equally here we'll do the same. The angle will use tan theta. Okay. So we say that for us to find the angle, it's supposed to be theta is going to be equal to tan inverse. Okay, tan inverse y over what? X. In a case where it's a negative, you do the same, but then you're supposed to do something else later. So we've seen that our x component is negative, we ignore that. So you have, where there's y, 5.9 divided by 8.4. Tan inverse of that, 35. So our theta is going to be, so 35. So your x is negative, your y is positive. In which quadrant do we expect the x to be negative and the y to be positive? It's in the second quadrant. Yeah. Okay. So we'll subtract from 180 since it's in the second quadrant. So therefore our angle becomes 144.9. So our angle is 144.9 degrees. So that's the way you need to present your answer. Okay. The magnitude, the displacement together with the angle. Okay. So let's try to move to the next question. It says the vector difference A minus B. So in this case, all you have to do is, let's indicate that it's A minus B. Okay. So you subtract the components as they are guided in the question. So it's A minus B. So the x component of A is negative 27.2 minus the x component of B, which is 18.8. 18.8. And what I'm getting is negative 46. So we have negative 46. For our y, it's 12.7 as the x component of A minus negative 6.8 as the x component of B. So what do we have? 19.5. Okay. So I won't show it. For now, we already know how to find the magnitude. So it will just be x squared plus y squared in the square root. So we have 46 squared plus 19.5 squared. The square root of that, we have 49.9. So our vector here is 49.9 meters. Then for us to find the angle, remember it's tan inverse y over x. Ignore the negative. 19.5 divided by 46. 0.42. Tan inverse of that, 22.9. But we need to ask ourselves a question. Why is x negative and y positive? It's in the second quadrant. So subtract from 180. So 180 minus 157. Okay, 157 degrees. Then finally, the last question is asking us to find b minus a. B minus a. So some of you may be saying, how is it different from a minus b? Okay, so this time around you subtract a from b. So for the x component, for example, instead of saying negative 27.2 minus 18.8, this time around we start with 18.8 minus 27.2. So we have 18.8 minus negative 27.2. We have 46, except it's positive this time around. Then negative 6.8 minus 12.7. Negative 19.5. So we are just changing the signs. So basically, if you do it, you find the same magnitude. 46 squared plus 19.5 squared, you find the same 19.9. Then how do you get to find the angle? You ignore the signs again. So 19.5, which is your y, according to this formula, divided by the x, 46, tan inverse of that, you have 22.9. But you need to find the actual angle. Look at the components. Where do we expect to find our x value to be positive and our y to be negative? It's in the fourth quadrant. So subtract from 360. You find 337 as your angle. 337. 337 degrees. Okay, so that's the way to go about it. Okay, we are on the third question now. So a particle undergoes 3 successive displacements in a plane as follows: 4 meters southwest, 5 meters east, 6 meters in a direction 60 degrees north of east. Choose the y-axis pointing north and the x-axis pointing east, and find the components of each displacement. The second part, the components of resultant displacement, the magnitude and direction of a resultant displacement, and graphically show the approximate displacement of a particle. Okay, so when you look at this question, it's a bit different from the first 2 questions that we've solved, because in this question, they are trying to use the compass to give you directions. Okay, so there are some of the key concepts that you need to understand when you're talking about the compass, in terms of giving direction. So let's try to look at that. So we all know this is where a compass comes out. Of course, we've been told that let the y-axis pointing north. Okay, so this is our y-axis, and that is our north. Then we're told the x-axis east, so this should be our east, and this is the way a compass is actually. Okay, so of course this becomes south and the west. Okay, so whenever they give you something in between, okay, whenever they give you something in between, it can be between the west and the north and the east. Okay, so I'll use the north and the east to give you examples. Okay, so when I'm moving from the east towards the north like this, so this is called north of east, because I'm moving from the east, I'm going to its north. But if I'm moving from this direction again, it becomes east of north. Okay, so whenever any of these are mentioned, which I should know that it has moved an angle of 45. Okay, because we know this O angle is 90. Okay, so that same applies to any of these other quadrants. For example, when I'm in the third quadrant, going down here means I'm going to the south of west. Then going up here means I'm going to the west of south. Okay, so the angle will be 45. Okay, so now let's try to apply these concepts to what we've been taught in this case. Okay, so remember the question, the first question is asking us to give the components of each displacement. Okay, so I think we're going to start with we'll move as we are given. So the first displacement that we are told is, we are told 4 meters southwest. So we'll draw a compass. Okay, 4 meters southwest. So we know that this is where our south is down here, then our west is to the left. Okay, of course that is our east and our north. So we are told 4 meters southwest. So this is what we have. So southwest, what does it mean? It means that we're going down. Southwest. Okay, 4 meters south of west. Okay, so this is a 45. Okay, so now how would you interpret that? So it's 4 meters, of course. So for it to resolve a vector into its components in such a case, how is it going to be? So remember from the previous questions, we've always said that our angle should be measured in respect to the positive x-axis. So this is the angle that we are interested in. So we know that from the east to the west, it's a line, so it's 180. So for us to find the full angle, it's going to be 180 plus 45. So our angle becomes 225. Our theta is 225. And I believe by now from the first 2 questions, we know that for us to find the x component, it's the magnitude multiplied by, it's the magnitude cosine the angle. So for the x component, for the first displacement, so we know it's 4 meters, of course. So the x component is going to be 4 cosine 225, which is negative 2.8. For the y component, it's going to be negative, it will be going to be 4 sine 225, which is also going to be negative 2.8. Okay, that's very important. Very, very important. Okay, how else are we going to move now? We move to the other one, 5 meters east. So that's straightforward. 5 meters east. So that tells you that you're moving from this point going this way, the east direction. So it's along the positive x-axis. So it will remain 5 for the x. For the y, there was no movement in the y, so it's 0. Then the other one, which says 60 meters, 6 meters, 6 meters, 60 degrees north of east, north of east. So it's of course 60 degrees north of east. So north of east, you're at east, now it's north. So that's the angle we're talking about, 60 degrees. So this is north of east. If I said east of north, would have started from the north. Okay, so this is actually the angle that we want because it's already in respect to the positive x-axis. So we have 6 meters. So it's going to be 6 cosine 60 for the x, and the y, it's going to be 6 sine 60, which is 5.2. Okay, so we've already answered the first question, which says find the components of each displacement. So we found the components of each displacement. So the second part says the components of a resultant displacement. The components of the resultant displacement. Okay, so the resultant displacement is going to be the addition of all the x and the y components, okay, respectively. So let's just try to add on the table, yeah. Okay, so I'll even use R to denote the resultant. Okay, so we have our resultant there. So the x component will add negative 2.8 plus 5 plus 3. We have 5.2. 5.2. For our y component, it will be negative 2.8 plus 0 plus 5.2. We have 2.4. So we found, okay, let me just try to, okay, so we have 2.4 there. So these are the x and the y components of the displacement itself. So we've answered the second part as well. The third part, the magnitude and direction of the resultant displacement. So the magnitude now and the direction. How do you go about that? The magnitude and direction. So how do you find the magnitude? So like I said, I've mentioned that in the previous, in the first two questions. So the magnitude is going to be found as the square root of the summation of the squares of the x and the y components. Okay, so of course we know the x component, in this case we've seen 5.2, and the y component is 2.4. So you add the squares of the two, summation of the squares, then the square root there. So 5.2 squared plus 2.4 squared, the square root 5.7. I'll do that again. 5.2 squared plus 2.4 squared, the square root of that. So I'm getting 5.7. 5.7 That's what I'm getting. We need to find the direction as well. So the direction we've mentioned, it's tan inverse of the angle of y over x. So I'll write that again. Tan inverse. So in a case where there are positives, it's direct. Whatever you get is the answer. In a case where there is a negative, there are some things that you're supposed to do, and I've mentioned them in the first 2 questions. So in this case, they're all positive. So it will be the y is 2.4 divided by the x, 5.2. Tan inverse of that, you have 24.7. So 24.7. So this is the way I said you should be presenting your solutions. Okay. So we've answered the third question as well. The final question says graphically show the approximate displacement of a particle. Okay. So let's try to show all this. Let's try to give a graphical representation of the way the particle had moved. So come up with our XY plane. Okay. So we'll start with the first one. The first one, we are told a particle undergoes 3 successive displacements 4 meters south of west. 4 meters south of west. So south of west is between the south and the west, right? Somewhere there. So we'll say that's 4 meters. So remember, this is let's try to just indicate. This is our west, of course. And this is our south. Okay, let me write that better. This is our south. This is our east. And the y-axis is our north. So we've shown the first displacement. Then we are told 5 meters east. So we moved 5 meters east. So it's supposed to move to the east. 5 meters east. Okay, so maybe let's say approximately that. It's supposed to be parallel to the x-axis. Okay, then we are told again 6 meters in a direction. So whenever you're drawing that, come up with the compass at each point. So like for example, for you to move 5 meters east, you're supposed to come up with a compass at this point. Okay. So east, you got the right. So we've moved that. So we can also come up with a compass at that point. So now they are saying 6 meters in a direction 60 degrees north of east. So north of east is between the north and the east. And it's north of east. So I'm moving from the east towards the north. So it's this way. Okay. So that's the angle 60. Okay. So meaning that it's going to be this direction. And what's the magnitude? The magnitude we are told is 6 meters. So it's supposed to be a bit longer. Okay. Supposed to be a bit longer. Somewhere there. Okay. So this is the way this is an approximate displacement. Okay, so in a case where you are using the compass and everything else, you're supposed to make sure that the lines that are drawn are exactly the meters that you're given, and you use a compass, your protractor, to come up with the angles. Okay, so I'll use a different color for the final displacement. So it's this is the displacement itself, the resultant. Okay, so then this now represents the angle that you found. It's supposed to match up with the angle which we determined. Okay, up to 24.7, so that angle. Then the length for the line should represent now the meters. that you determined the length. Okay, so this is your resultant. So that's how you graphically show it. Okay. Okay, the last question in this video. The resultant of two forces, vectors A and B, has a magnitude of 150 newtons along the y-axis. If a force vector B makes an angle of so that was supposed to be 60 degrees. Okay. With the positive x-axis, find the magnitude of B and the direction of A, given that the x component of A is equal to negative 60 newtons. So as advised, it's very important for you to attempt a vector question that first of all you come up with a table that is going to show the components of the vectors that are involved. So a force is a vector because it has direction. Okay, so how are we going to show that? Let's come up with a table and show the vectors that we have with their components. Okay, so of course every vector should have the x and the y components. And how many vectors do we have? We have A, force A and force B, then we have the resultant itself. Okay, so we have the x, each vector should have the x and the y components. Then we have force A, we have B, then we have what? The resultant. Okay, so remember, all these vectors should have what? Should have a magnitude. Okay, so I'm going to show the magnitudes to the left of the table. Okay, that's where I'm going to show the magnitudes. Okay, the size of the vector itself. So what are they saying? So the resultant of two force vectors A and B has a magnitude of 150 newtons. So that's, we've already been given the vector itself, the magnitude of the resultant. So it's 150 newtons. Okay, so let me use a different color. So it's 150 newtons. That's the resultant, the magnitude. Okay, what have we been told? It's along the y-axis. So this means that after all the vectors, after all the components are added, the resultant is along the y-axis. And what does that tell you? It tells you that the x component of the vector is going to be what? So the x component is going to be 0 because it's along the y-axis. Then the y component automatically becomes 150 as well. Okay. Of course, we know the units are newtons because we're talking about forces. What is there any more information we've been given? Yes. Okay. So if the force vector B makes an angle, so that was supposed to be 60 degrees with a positive x-axis. So we've been told vector B is going to be somewhere there, and it should make an angle of 60 degrees. So that is vector B. We don't know the magnitude, but we've been given the angle. Find the magnitude of B and the direction of A. Given that the x component of A, so we've been given the x component of what? A to be negative 60. So we have negative 60 there. Okay. So we have got two unknowns for the y. So it's not easy to find two unknowns, but it's easier to find one unknown there. Okay. So we know the addition of negative 60 plus the x component of B, which I'll use B, x, to denote the x component of B, should be equal to 0, the resultant there. Okay, so therefore Bx is automatically going to be 60 newtons. Okay, so we found the x component there. Okay. But we also know the direction of B. We also know the direction of B. How else can we find it? So we can say, okay, let the magnitude of B, let it be just, let's use B. Let's say the magnitude of B is B. Then we'll say the magnitude of B cosine 60 should be equal to the its x component, because this is the way we find the x component. We use cosine. So it should be able to give us what? 60, because that is the x component. So this is going to help us find the magnitude of B. So it will be 60 divided by cosine of 60. So if you get your calculator, 60 divided by cosine 60 is 1 over 2 or 0.5. So it's automatically going to be 120. So you've already answered the first part of the question, which says find the magnitude. Okay. So remember, we've mentioned this in the first 3 questions to say we find the x component by multiplying the magnitude cosine the angle. So we used the relationship of the components to find 60. Then we now use the relation of a vector itself, trying to resolve it into its components. So we've equated the two and we found 120 Newton as the magnitude of B. Then the other question is asking us to find, of course, the direction of A. So it's very important that before you get to find the direction, you find the components. Okay. So let's try to indicate what we've already found there. So we've already found now the magnitude of B. It's 120. I can even indicate it there. So it's 120. So how do we find the y component now? It's going to be 120. And we know, of course, the angle in the question was given to be 60. So it's going to be 120 sine 60 for the y component, which is 103.9. I'll indicate that. 103.9. So now that we have the two y components, we are able to find the y component of A. So we'll say AY plus 103.9 should be able to give us what? 1/5. So let me create some space for. So after adding the two, you're supposed to have 150. So AY becomes the difference of 150 and 103.9. So what do we have as the y component of A? So 150 minus 103.9. I'm getting 46. 46.08. 46.08. So which is approximately 46.1. So that is our y component there. That is our y component. So we found our x and the y components. Then we of course know that direction can be given in terms of an angle. So how do we find the angle? So we've mentioned that it's tan inverse the y component over the x component. Okay. In this case, what do we have as our y component? It's 46. What is our x component? 60. So I'll ignore the negative. So whatever we're going to find there is not going to be the exact answer because I've ignored the negative. So tan inverse of that is 37.5. So that is not the answer. That's not the final answer because I ignored the negative. Okay, so you go to the quadrants. So we know that our x component, we've seen it's negative. So it's obviously going to be towards the left. But the y component is positive. So it's obviously going to be somewhere there. So for you to find an angle in the first quadrant, or in the second quadrant, you subtract from 180. So the 37.5 is here. Okay. So for you to find the angle in respect to the positive x-axis, you subtract from 180. So we have our angle or our direction becomes 142.48 degrees. So this becomes the direction of what? Of A. Okay, so that's it for this video. I just hope that these 4 questions gave you a strong foundation under vectors, and I believe you won't find any challenges when it comes to solving vector questions. Thank you very much for watching, and have a good day.